Okay, this is the second part of the reading from pages 19 through 27. This is going to be pages 22 through 27, and it is surface water, and this is going to focus on still water or not moving water, so ponds and lakes. Here we go. Ponds and lakes are bodies of fresh water, like rivers. But unlike the moving waters in streams and rivers, ponds and lakes contain still or standing water. How can you tell the difference between a pond and a lake? There's actually no definite rule, but in general, ponds are smaller and shallower than lakes. Sunlight usually reaches to the bottom of all the parts of a pond, but most lakes have an area where the water is too deep for sunlight to reach the bottom. The five Great Lakes like Huron, Ontario, Michigan, Erie, and Superior, our own Lake Michigan. It's one of the largest lakes. Those are ginormous lakes, and they definitely don't get sunlight all the way to the bottom. There are lots of lakes, however, in the United States, many of them much smaller than the Great Lakes. And if you can see light at the bottom, it is generally considered to be a pond. And it doesn't, of course, have to be a lot of light, but as we talked about with oceans, water doesn't get below 200 meters. Light didn't really reach below 200 meters. So anything that is where the light doesn't reach the bottom of the body of water would be considered a pond. Or where light does reach the bottom of the body of water would be a pond. How do they form? Well, ponds and lakes form when water collects in hollows and low-lying areas of land. We know that water runs off the land. Sometimes it might run into a lake where it's moving water, but sometimes it'll collect in an area where it's not reaching another body of water. And so it sort of creates just a place where the water's collected, much like a puddle on the ground. It doesn't feed into another body of water, but obviously at a much larger scale. So ponds and lakes form when water collects in hollows and low-lying areas of land. Where does the water come from? Some ponds and lakes are supplied by rainfall or melting snow and ice and runoff. Sometimes, though, they are actually fed by a river or groundwater. As a pond or lake gains water from those sources, it also loses water to other natural processes. For example, water may eventually flow out of a body of fresh water into a river, but water can also evaporate from the surface of a pond or a lake. So sometimes in I think it's Arizona, Nevada. You have Lake Mead, and Lake Mead is actually fed by the Colorado River, but they have a dam there, so it sort of pauses there, and then they can also allow the water to move through. So it can be held by natural processes as well as man-made. And this diagram, you can see in this case, like the water is reaching the bottom, so they're focusing on ponds here. Exploring a pond. A pond might seem calm and peaceful at first glance, but if you look closer, you'd notice the silvery minnows gliding beneath the surface. Plop! A frog has jumped into the water. A quiet pond is actually a thriving habitat supporting a wide diversity of living things, as shown in Figure 13. There's a lot of organisms that depend on ponds for their habitat. If you've ever waded into a pond, you know that the muddy bottom is often covered with weeds, kind of squishy and yucky in your toes. Because the water is shallow enough for sunlight to reach the bottom, plants can grow throughout a pond. Plant-like organisms called algae also live in the pond. As plants and algae use the sunlight to make food through photosynthesis, they also produce oxygen. And oxygen in the pond the animals in the pond use the oxygen and food provided by the plants and algae. So they have what you would call a symbiotic relationship. So the fish here rely upon the plants in the pond to make the oxygen that it breathes. So it really needs those plants. All right. Down here, we have the shore of the pond that we're exploring. We talked about the animals there, and we have some other organisms in that pond. Lakes. Now, there's a couple of different types of lakes, and they are formed either by natural processes or human processes. When I was younger, we used to go to this lake in Wisconsin, and we always would be like, is this a man-made lake or is this a natural lake? So our humans do make lakes. Lake Mead would be a man-made lake. Exploring a lake. Suppose you were shown a picture of a sandy beach. Waves are breaking on the shore. The water stretches as far as the eye can see. Gulls are screeching overhead. Where was this picture taken? Well, your first guess might be the ocean, but this immense body of water could be a lake, such as Lake Michigan. We know how big that is. You could be viewing a photo of a beach in Indiana on the shore of Lake Michigan. Most lakes are not as large as Lake Michigan, but recall that lakes are generally deeper and bigger than ponds. A lake bottom may consist of sand, pebble, or rock, whereas the bottom of a pond is usually covered with mud and algae. No water is getting to the bottom of that lake, so it's not going to have any plants growing down there. Once you're out deeper. In the shallow areas, it might. In the shallow water near shore, the wildlife of a lake is similar to that of a pond. Water beetles scurry over the slippery moss-covered rocks. Loons and kingfishers pluck fishes from the open water. Those are types of birds. But sunlight does not reach the bottom of a deep lake as it does in a pond. As a result, only a few organisms can live in a lake's chilly, dark depths. There are no plants, but mollusks such as clams and worms move along the lake bottom. They feed on food particles that drift down from the surface. Deep lake waters are also home to large bony fishes such as pike and sturgeon. You know, a lot of people like to go fishing in lakes. These fishes eat the tiny bottom dwellers. They also swim to the surface to feed on other fishes and even small birds. So here we've got a couple of different types of lakes, and I talked about Lake Mead. On the left here, we have a glacier-made lake. This is Lake Louise in Alberta, Canada, and it's formed by the movement of glaciers, so it is a natural lake. Beautiful. You can see the headwaters might be up here. If this lake was feeding a river system, you could see that melting snow would run off into there. Over on the right here, we have a human-made lake. This is the Lake Mead Reservoir, as part of the Hoover Dam complex in southwestern United States. And if you look here, I talked to you about how this Lake Mead is fed by the Colorado River, and they put this dam up. It stops the water from flowing, but they allow the water to go through. They can turn on the turbines, and the water will go through, as we read about, can create electricity, and then it will continue on down its way. But right now, that's Lake Mead. That line, by the way, that you're seeing there, it's fairly large. It's pretty significant. That is how high the water level used to be, but there has been a drought for many, many years, and that water is actually being sucked out for the seven states around it to be used. So the Lake Mead water is being depleted very rapidly. Lake formation. As you read earlier, lakes and ponds form when water collects in hollows and low-lying areas of land. Let's take a closer look at some natural processes that can result in the formation of a lake. A river channel, for example, the body of the bed of a river, the river channel, where the water flows through, can form. The river channel, for example, can form a lake as it changes over time. It bends and loops as it encounters obstacles in its path. Eventually, a new channel might form, cutting off a loop. The cutoff loop may be an oxbow lake. And essentially, what happens with an oxbow lake is you have these curves in the river, okay? But over time, what happens is this water flows out. It'll flow faster and faster here, and faster here, and slower here. And eventually, it's going to fill in here, or it's going to move faster and faster here, and it's going to cause this to move further and further out. I know it's hard to see. This will move further and further out. And then eventually what's going to happen is the channel is going to break through, and this will fill in. And you will get this oxbow lake over here. And I know that's very simple, but we'll draw that in class too. Some other natural lakes, such as the Great Lakes, formed in depressions created by ice sheets that melted at the end of the Ice Age. So that we showed you Lake Alberta. Other lakes were created by movements of Earth's crust. So like the shifting apart and forth. Such movements form deep valleys in Central Africa that lie below Lake Tanganyika and Lake Victoria. Still, other lakes are the result of volcanoes, where you might get a volcano, like a mountainside of a volcano is like a mountain, and the top of the volcano will have filled in with rock and dirt, and water can collect in there, and you get a lake at the top of a volcano. So an erupting volcano can cause a flow of lava or mud that blocks a river and forms a lake. Some lakes form in the empty craters of volcanoes. People can also create a lake by building a dam, like Lake Mead, by building a dam across the river. The lake may be used for supplying drinking water, for irrigating fields, and for recreation. A lake that stores water for human use is called a reservoir. So there we have it there. So again, I wonder if they have, so this is Lake Alberta. As they said, this is formed by glaciers. This is Lake Mead, that is a man-made lake. And this is a volcanic lake in Costa Rica. So the top of a crater, water is collected. Okay, going down here to how lakes can change. A maple tree in the fall looks very different than it does in the summer. The green leaves change to brilliant shades of red, orange, and yellow. Lakes can change with seasons too. Lakes change for many reasons. In addition to some of those seasonal changes, a lake can also undergo these long-term changes that eventually lead to its death, or essentially where the water eventually evaporates and the lake sort of dries up. That would be the death of the lake. Some seasonal changes that occur in a lake. Seasonal changes in lakes are common in cool northern areas of North America. In the summer, the sun warms the upper layer of the water in the lake, and the warm water floats on top of the cooler, denser lower layer. We know that. But in the fall, the top layer will actually cool off more than the bottom, because the bottom is sort of being warmed by the earth then. As the top layer cools, it becomes denser and sinks, and it causes the lake water to mix. This mixing, which is also called lake turnover, just like upwelling, causes materials to rise from the lake bottom. So you have that colder, denser water when it cools off outside sinking, and it pushes some of that water and those nutrients up. Lake turnover refreshes the supply of nutrients throughout the lake. Nutrients are substances such as nitrogen and phosphorus that enable plants and algae to grow. The second type of change that may occur in a lake happens over a long period of time. The organisms in a lake constantly release waste products into the water. The waste and the remains of other dead organisms contain nutrients such as nitrates and phosphates. The algae will feed on those nutrients, but over many years, the nutrients will build up in the bottom of the lake in a process called eutrophication. So that word right there is eutrophication. As eutrophication causes more algae to grow, a thick green scum forms on the surface of the water. So if you've ever seen a lake sort of covered in like algae or an algae bloom, that's eutrophication. That means they've gotten more nutrients than they are used to. So they've gotten a lot of phosphorus and a lot of nitrates, which actually helps those plants grow, which you might think is a good thing. But then recall that algae are present in ponds and lakes, so it can occur in ponds. I'm sorry. So what happens is as those plants grow, though, it'll block the sunlight out and everything else down there will die and it will cause the lake to fill in. We're going to read about that here. So it says here, the process begins as algae and other organisms add nutrients to the lake and they support more algae growth. So the more you have organisms dying and more, sometimes you get runoff from farmers who are feeding their crops and that stuff helps those plants to grow, then the algae will begin to bloom. So you can see that happening. And then soil and fallen leaves and decaying matter, they'll pile up on the bottom of the lake and the lake will become shallower and shallower and marshy. So you can see that. And then eventually plants will completely fill it in, creating a little meadow where all that water is evaporated. Okay? That's the death of a body of fresh water. When the algae layer becomes so thick that it blocks out the sunlight, plants in the lake or pond can no longer carry out photosynthesis. They no longer have the ability to. They stop producing food and oxygen and they die. As dead organisms in the water decay, the amount of oxygen in the water decreases. So that will kill the fish, right? Many of the fish and other water animals no longer have enough oxygen to live. Material from the decaying plants and animals pile up at the bottom. So all the things that were once living in the lake eventually die. They'll sink to the bottom and will start to fill up. And the lake or pond becomes shallower. The sun warms the water to a higher temperature, then more plants take root at the rich bottom, and eventually the body of fresh water becomes completely filled in with plants. The remaining water will evaporate, and a grassy meadow ends up taking the place of the former lake or pond. Eutrophication, though, is not the only change that can lead to the death of a lake or a pond. Sometimes water can leave a pond more rapidly than it enters. This can happen when the source of water for a pond, like a stream, dries up or is cut off from the pond by a natural process such as erosion, like in an oxbow lake. In addition, streams and rivers carry sediments into ponds or lakes, and over time, these sediments can fill in the body of water. We are done with our section there. We're not going to do the section assessment. Our next section will be on groundwater, and we will be reading that shortly. See you then.